the square root of 7.1 square plus 2.9 square. And then the special instruction is that we are supposed to give our answer correct to two significant figures. What we want to do here is just to work out this quickly. So I'm just going to drop this here. So 7.2 square. So we want to use our calculators. 7.1 square, should say. That's about 50.4. 50.41. And I'm going to add that to 2.9 square. That's about 8.4. 8.41. Let's add these together. We're getting, so 8.41 plus 50.41. That's about 58.2. 58.82. And then we take the square root of this. So the square root of that. All right, so I'm just going to write what I get. So we get 7.6694. But remember the context of the question, two significant figures. If I'm going to round this off to two significant figures, this is going to be my spot. So it's going to be 7.7 to get that 1 mark. So the bottom line is you want to make sure that you're not making any errors as you go. All right. Second question, we're going to put this to 2 decimal place, the same response. So this to 2 decimal place, I'm focusing on this, and then I look here. So I'm going to round up to 7.67. All right, very straightforward. So those are easy marks that everybody should be picking up. All right, so easy marks to pick up right there. Let us write the following quantities in ascending order. All right, what you want to do with a question like this is probably to represent everybody as a decimal quickly. So we could represent this as a decimal. So 12, divide that by 25. This is the same thing as 0.48. 47% is the same as 47 over 100, which is 0.47. So having had everything in decimal, now I am able to easily put it in ascending order. So from smallest to largest. So it's going to be 0.46 followed by 47%, followed by 12 over 25. All right. So you want to follow very quickly, put everything using an equal idea. In this case, we're using decimals, and then we represent that. All right, let's take a look at this question. It says here, Mahindra and Java share $7,224 in the ratio 7 to 5. How much more? All right, so it's how much more money does Mahindra receive than Java? So you want to take a look at this here. This one is for, I'm just going to call this person M. I'm going to call this person J. All right. So the total here, as you could see, is actually 12 parts that we're dealing with. So there are various ways that we can work this out. So what we want to do is to find both, and then we subtract. So I'm going to work out Ma, just shortening the name. So that is, Ma is 7. So I'm going to work 7 out of 12 off that money, which is 7,224. So we want to work that out. 7 divided by 12 times 7,224. And this person is getting $4,212. Let's work out Java. Java got 5 out of the 12. So 5 over 12 times 7,224. Work that out. 5 divided by 12 times 7,224. And this person is getting $3,010. So how much more we're referring to? We're going to have to subtract. So you want to subtract. And we're getting $1,214, right? So there it is that we have. I'm just going to shout this person name. Let's write it. Mahindra got $1,214 more than Jaha. Second question. So part 3, it says the present population of Portsmouth is 550,000, right? It is expected that this population will increase by 42% in 2030. All right. Now, what they want us to do is to write this number here, 550,000, in standard form. Remember, standard form is written as a times 10 raised to the n, where a is a number less than 10 greater than or equal to 1, and then n is an integer. What it means is that I'm going to have to make sure that my decimal point comes after the first non-zero digit. So if you want to write back all of these, you can, but it's not necessary. So basically, this is the idea. 5.5000 times 10 raised to what power? Let us check to see how many places did we move it. 1, 2, 3, 4, 5. So we actually move the decimal 5 places to the left. So it is actually 5.5 times 10 raised to the 5th power. And that will give us the answer. If you have this, it's the same thing. So if you have 5.5 times 10 raised to the 5th, you're still good. All right. Let's take out the second part to part C. It says calculate the expected population of Portsmouth in 2030. Now remember, it's going to increase by 42%. There are two ways we could approach this. Solution one is that we could understand that this 42 will be added to 100. So at that time, it's going to be 142% off what it is now. This could take you straight to the answer. So you could put 142 over 100. If you multiply this by 550,000, you will get the answer, which is 781. So this is going to be the population at that time. But this is solution one. That is solution one. Solution two, most persons probably do this. You find 42% of the 550 and add it back to it. So you can do it that way, all right? So 42% of 550,000 is going to give us 231,000. So now what we're going to do now is to combine the 550 plus the 231, and we're looking at 781,000. So whichever way you work this, it doesn't matter, right? You could take approach one, approach two. We're going to end up having the same value there. You'll get the same 1 mark. So it's an easy cheese, nothing to stress over. So far, so good. Everybody should actually be collecting those marks right now. So far, so good. All right, let's jump onto this question. This question says, the graph below can be used to convert between United States dollars, which is US, and Eastern Caribbean. So you're seeing Eastern Caribbean and the x-axis, and US is on the y-axis. It says using the graph. And then very important thing here, it says using the graph, what we want to do is to convert to US to EC. So what you want to do is to take this. Let me take this graph to my other screen. We'll take this to the other screen very quickly right here. All right. So all right, let's take a look at this. So what we're looking at is $2. Quickly, want to see where $2 US. So we want to make sure 2 that we're reading. So 2 US to EC. Let's go back. 2 US. I'm going to take a line and I'm going to take it where 2 is. Right here. And the moment it touched the graph, I'm going to stop and I'm going to take it down from here. So all I'm going to do is to interpret what's going on right here, right here. So based on what we're dealing with, right, we can see this is, we're moving by 0.2, all right, 5.2, 5.4, 5.6, 5.86. So this that we're at, this marker is actually $5.40. All right, so we're picking up that from the graph right there. And when they said use the graph, you want to show these lines. You have to show these lines on your graph in order to do that. So what we're looking at here is we got $5.40, right? So it came down right here. That's where it came out right there. So that's $5.40. All right, let us jump onto the other question. So the other question says we're still using the graph. What we want to do is that we want to convert US 70. We want to convert EC 70 to US. So what we're going to have to do is to use the graph to do an idea. Remember, it's a straight line. So the idea remains constant. So I want to look at EC 70, even though there's no 70 here, but I could relate EC7 and then I multiply by 10. So I'm going to use EC7 here. I'm going to definitely use this graph because we're supposed to be using the graph. So I'm going to take up 7 right here. So if I take 7 here, this is where it's going to take me. All right, so 7 would have taken me right here at that line. Boom. All right, so I'm actually getting a nice line right there. So 7 would have taken me right over here. So what we want to do over here is that do over here is to try to see what this is right here. So this is 2.2, 2.4. This is 2.6, right? So right here, this line came across at 2.6 right there. Therefore, we are able now to make that link. So it came across at 2.6. So 7 came across at 2.6, and we're going to be using that. So let's go back to this. So basically, using the graph, EC $7 was equal to US $2.60. Therefore, right? Therefore, EC 70, because if I multiply the 7 by 10, I get 70. Then if I multiply the $2.60 by 10, it's going to give me US $26. All right. So that is how we could easily represent that idea. All right. So 70 would link to $26. All right. So we're going. Now we're looking at a question here talking about seabed. So it says Lana needs to put mesh around 2 seabeds, right? Mesh around 2 seabeds to protect her seedlings. So altogether, she used 60, right, meters to mesh that around. All right. On one of the seabeds, one of the seabed is a rectangle, the other one is a square, as we could see here, as shown in the diagram. So we're going to get some specific details now relating to the question. The width of the rectangular seabed is X, and we're seeing that they gave us this, so we're seeing this right here. And then now it says the length is 3 times the width. So that means I'm going to just represent this as 3x. Also, we were told that the square, we're told that the length of a side of the square is y, and that is actually there. Using the information given, derive a simplified expression for y. All right. So what we want to do is that the idea about this is that this is also 3x and this is x. This is y, this is y, this is y. So what we're saying, they want us to represent y, but what we do have is that if we should add up this perimeter of the 2 shapes, right, it's going to equal to 60, right? So what we could do here is that if I add up the one for the rectangle and subtract it from 60, I'm going to end up getting the one for the square. For example, I'm saying this. We could just look at that. 4y, because if I add y plus y plus y plus y, 4y is equal to 60 minus whatever we have for the perimeter for the rectangle, which is 3x plus x plus 3x plus x, right? So basically, I'm just saying 4y is equal to 60 minus, this is 6, this is 8x. And then now y alone, because we were told to find y, I'm dividing by 4, y is going to equal to 15 minus 2x. So that is the value of y right there in terms of x. So y is equal to 15 minus 2x. All right, so we want to make sure that we have this down. The length y is 15 minus, y is equal to 15 minus 2x. And it simply means that at any given time, I can substitute 15 minus 2x for y. All right, let us jump on to the next question. The area of the rectangle seabed is equal to the area of the rectangle seabed is equal to the area of the square, right? All right, good. So we're getting that. So the area of that is equal to the area of that. So it says use this information, use that information and your thing to write a quadratic equation in terms of x to show this. All right. All right. So we're looking at the fact that the area of the rectangle seabed is equal to the area of the square. All right. So both of them are equal. So what we can do then, we can put all this together, right? So let's take a look at this. Take a look at this. So what we have here is, remember now that 3x times x. So this is the rectangle one right here, which is 3x, and this is x. So length times width is equal to, remember this is 15 minus 2x. All right, 15 minus 2x, right? So basically then, this is 15 minus 2x all squared. So if you break down this now, all we got to do is to simplify this. So this is 3x squared. And let us say we put this here. I'm going to just put this right here, 15 minus 2x. I'm going to multiply this by 15 minus 2x again. And if we should distribute, 15 times 15 is 225. 15 times 2x is going to give us negative 30x. Negative 2x times 15, negative 30x again. And then negative 2x times negative 2x is positive 4x to the second. So on this side, this is what I have when I simplify this idea. I have 4x squared minus 60x plus 225. That's what I have. Now, in this case, we want to represent the idea such that it shows like this. So what we're going to do is that we're going to subtract 3x squared from both sides. So we get a 0 on this side. 3x, so 4x squared minus 3x squared is going to give us x squared minus 60x plus 225. And there it is. We would have shown getting back that as what they gave us. So this is us representing, and we got that, right? That means everything that we have done so far in relation to this is actually accurate. Now they're asking us to solve this, right? So solving this, when I'm checking this out, it cannot be factorized, right? So what we're going to have to do is that we want to list what is A, B is negative 60, and C is 225. We're going to set up our quadratic formula where x is equal to minus b plus or minus the square root of b squared minus 4ac. All of that must be over 2 times a. So let's go for it. Minus b and d is negative 60. So we have a minus there. Plus or minus the square root of negative 60 square minus 4 times a times c. And all of this must be over 2 times a is 1. Let's go again. When the two negatives clash out there, we're actually looking at positive 60 plus or minus the square root of 3,600 here. And this is minus 900 here, all over 2. Let's keep going. We're looking at 60 plus or minus the square root of, this is 2,700 all over 2. All right, let me double check that number there. 36 minus, yeah, it's good. 2007. All right, so we're almost there. We're almost finding x now. So x, so let us find the square root of 2,700. All right, so 51.96. So what we actually have here is that 60 plus or minus 51.96 over 2. So let's work it out. So x is equal to 60 plus 51.96 over 2. So let's work that out. 60 plus 51.96 divided that by 2. We're getting about 55.98. All right, so that's one value. And in the second instance, x is equal to 60 minus 51.96 over 2. 60 minus 51.96. So we have 8.96. 0.04 over 2. So I'm getting x to be 4.02. Okay. All right. So I have two values for x here. I'm just going to highlight them. I have this as a value for x as well as that as a value for x. All right. So we have two values for x right there. Now, let's see what the next question says. The question says calculate the area of the two seabeds. All right, so we want to find the area of the two seabeds, all right? The area of the two seabeds. Now we're gonna have to check out the sides to see if they make sense in context. So let's go back, right? All right, let's see. Let's see if the sides would make sense, right? So when we are here, take a look at what this is. Remember that y is equal to 15 minus 2x. Now, if I go ahead and plug in the 55 point, what we have here, 55.98. If I put 55.98 here, take a look to find what is y. So 15 minus 2 times 55.98, you're going to realize that there is an issue here, right? So 15 minus 2 times 55.98. You're going to get a negative number, right? This is negative 96.96. And this cannot be, right? So we're going to have to ignore one of our quadratic answers in terms of to put this in a real world context right now. So the answer were 55.96. It is theoretically correct, but for the situation, it cannot be because we'd have a negative side and we cannot measure and get a negative length, all right? So because of that fact, we're going to have to we can only use the 4.02 to work with here. So we're going to use the 4.02 to work out the area. But as you could see, so let's go back. So 4.02 is good. So take a look. So we're looking at having, remember, you know, if I should go for the ideas that we got, let me show us the ideas that we got right here. The ideas that we got right here, this idea is actually representing the area. This idea, because we have area equal area here, and we broke this down, right down. So whichever way you want to do it and put it together, you could do it like this. Take a look. 3x squared was for the rectangle, right? And for the square, it was 15 minus 2x squared. So if we substitute our values there, right? So all we got to do is to substitute x equal to 4.02 because we just realized that if we use the 55.98, we'll get a negative side for the square, and that can't work. So right here, we're just substituting. We're just going to add these up. 4.02, we square that. We're going to add this up, and it's going to give us the area of the two seabeds. So let us just go ahead and do that, right? Let's just go ahead and do that. So 4.02 squared, that's 16 point something times 3. I'm getting 48.48. All right. So that's one there. 15. If you want to square this, what if you want to work one more step? You could. That's a negative. You could work out what is inside the parentheses there. So 4.02 times 2. Yeah. So, all right. So this is actually, when you work out this, you're actually going to get 6.96 right here, right? This is actually 6.96 if you square it. So let us square 6.96. All right, we're getting back the same thing. But remember that we were told that the area was the same, you know. All right, so we round this off. But at the same time, we're still getting a 48.44. So basically, we could have doubled this and we would have been good based on the context that the two areas are the same. We find one, we could double it. Remember that we round off these figures here. So when you round them off, you're going to shave off a little bit. But we could add these and we still go 48.48 plus 48.44, and we get somewhere 96.92. We could round this off to approximately 97, right? So we're looking at about 97 units square right there, depending on whatever units that were used there in the question. Let me look if it was meters. Yeah, it was meters. So we could round it off to 97 meters, square meters right there. So that's the area. All right, let us take a look at question 3 right here, right? Let's take a look at question 3. So question 3 says a vertical flagpole, FP, right? So a vertical flagpole, FP, stands on horizontal ground and is held by 2 ropes, PG and PR as shown. All right, so we're looking at this. PG, so all the measurements are given, the angles are given. Let's jump right into the question. It says calculate the height of the flagpole, right? Calculate the height of the flagpole. In other words, we want to find that distance over here, right? We're trying to find this distance right here. All right, so basically, it's a right angle triangle. So we want to think right away to tower, right? So for this angle 38, we're dealing with the hypotenuse, and they want us to find the opposite. So I'm going to use sine. So the sine of 38 degrees is equal to FP that they asked me for over 18. And right now, you could do your cross multiplication or whichever way you want to do this. You multiply both sides by 18 and you're done, right? So this answer is 18 sine 38 will give us the answer. 11.08 meters is equal to FP. Or you could say 11.1 meters, right? All right, so we have 11.1. I'm going to use 11.1 right there. So right here we have 11.1 meters for that height. All right, let's keep going. Find PR. So what we want to find is PR, the length of one of the pieces of the rope. So let's take a look. PR. Where is PR? PR is right here. Now, if I highlight this triangle, then we could easily use the Pythagorean theorem on PR. It's the hypotenuse, so we could say PR squared is equal to 11.1 square plus 9.7 square. We're working with that. So 11.1 square is going to give us about 123.21 plus 9.7 square. We're getting 94.08. So we're almost there. PR square is equal to, let's add it, 123.21 plus 94.09. This is about 217.3. So all we want to do now is to take the square root of that. All right, so if so PR, we take the square root of both sides. PR 14.74, 14.7. All right, 14.74 meters. And we could say 14.7 and we're good to go. So we use the Pythagorean theory on this because this is a right triangle. We have 2 sides to find the third sides. Not a big deal. All right, let's keep going. All right, let's take a look at this question. So this question says, in the diagram below, right? So in the diagram below, PQ is parallel to MN. We're seeing that. LRT is an isosceles triangle where this is the key thing here. LRT is an isosceles triangle. All right. Triangle SLT is a straight line. All right. So SLT is a straight line, I should say. Where's SLT? So you want to mark those off. SLT is a straight line. All right, good, good, good. All right, so let us put some ideas together here. This definitely we know that here is 28 because that's a Z angle right there. So it says find the value of X. So in other words, then if I take a look at X, vertical angles are equal. All of this angle here is X. All of that angle, vertical angles are equal. So if I look at the crisscross, this and this, right? So vertical angles are equal. So if I'm able to just find these values in this triangle, then I will be good. Now, we were told that we have an isosceles triangle here, right? So it means then, based on what we have, that this is equal to this, right? So this is the angle that is different. So I'm going to plug that angle out, right? So if I take that angle out of 180, so 180, I'm going to subtract 28. I'm going to get 152, and I'm going to share that equally. So this is 76, and this is 76, right? So what we're saying is we end up with 152 divided by 2. We end up with 76 for each. Now we can combine this to find that. All right, so angle X is equal to your 76 plus your 28. That's about 104. We're getting 104 degrees right there for this. So we put together the ideas and we keep going, keep going, keep going. All right. All right, let's go to question. So this is the next question here. So it says here that the diagram below shows a shape T and Q after transformation, right? So we have, so the image is Q and the original shape is T. So this is our object right here. And this is its image over here right now. All right, that's what we got. So based on what you have read, you would have gotten that. So the question says here, describe fully the single transformation that maps the T onto the Q, right? So what it is that move this onto this. You have to observe carefully, and the moment you start looking at it carefully, you're going to realize that this is a reflection, right? You look at this good, you're going to realize that, hey, this is a reflection in the line where y is equal to x right now. It's a reflection in this line. Take a look. So it is a reflection in that line where y is equal to x. So you're seeing that going across here, this going across there, this going across there. So definitely this is a reflection. Across y equal x. So that's what we have there. That's a reflection across y equal to x right there. Next thing they said, on the same diagram, what we want to do is to draw, right? We want to draw the image of T, the image of the shape T after it undergoes a translation -1, 6. All right, so we can actually do this and call it M. Can do this a number of ways. We could just move the points and bring it to its new location. So I could just operate on this. We're gonna move these. I'm gonna just move them. Let's just move them. All right, so we could use algebra, arithmetic, and add, or we could just move it. So remember now, the translation is -1, 6, which means that you're going to move one place to the left and 6 up. So if I pick on this point here, I move it 1, and then 1, 2, 3, 4, 5, 6, it lands here. Then I'm going to move the other point. I'm going to move this point here, 1 to the left, and then 1, 2, 3, 4, 5, 6. It lands here. This one to the left, 1, 2, 3, 4, 5, 6. It lands here. Last one to the left, and then it moves 1, 2, 3, 4, 5, 6. It lands here. So you could see that you could just move it around and then reconnect your shape, and you get your marks just the same. So all you have to do is to take your ruler and you take your time and you reproduce your shape here. And this is the translation. And in these exams, you don't want to use freehand, all right? Remember, I'm just doing this right now. and you're going to call this m. So that's the translation here that moved this up here. And you would have gotten all your marks by just doing that. So that's what we have there. And boom, right? Now we're starting question 4. Question 4 says a rectangle PQRS has diagonal P and R, where P is this. Okay, this is the point P and this is the point R. All right, good. So that what I want us to do now is to calculate the length of PR. Remember now the distance formula suggests that PR is going to be equal to this. I'm going to drop this and then we go back to that. PR is equal to x2 minus x1, then we're going to square that, plus y2 minus y1, and then we square that. So let us label our points here. So we have, so here it is, here it is. So -3, and so I'm going to call this x1, y1, and then we have 4, -4. I'm going to call this x2, y2. So let's put it together now. Square root of x2, so it's going to be 4 minus x1, -3. Be careful here with this, plus y2, which is a -4, minus 10. All right, and we square. Let's keep going again. The two negatives here will give us a positive. So this is +7 we're looking at. Negative and a negative. So this becomes 7 square. Plus this is -14. Be careful with your calculator with the negative numbers, right? So this is going to be 49 plus 196. All right, so when you square that, you get 196. So let us see what we actually have. 196 plus 49 is giving us the square root of 245, right? So if we take the square root of 245, so this is the answer already. Square root of 245 units long, all right, which is approximately 15.7 units long if it's rounded off, right? So definitely your answer is right there and you're good. So that's the distance formula you want to use quite easily there, and then you're good. The next question says determine the equation of PR. We're still dealing with the, so let us grab back the points for PR here. Let me write back the points here. We have -310, and we actually have 4, -4 here, all right? So basically then what you can do is find your slope. So if you want to label x1, y1, x2, y2, remember that your gradient is equal to y2 minus y1 over x2 minus x1. So let us put that together, right? So you're dealing with y2, which is -4 minus 10 over x2, 4 minus -3. We're looking at -14 over 7. And so my gradient is -2. So I have my gradient. So what I'm going to do now is to take the gradient and a point. So if I have my gradient, which is -2, and I have a point, so gradient is -2, and I could use any point. I might just use 4, -4. Remember that this is x and this is y. All I want to do is to find my y-intercept. So remember the format that y is equal to mx plus c. So I'm going to substitute. -4 is equal to m plus c. Keep working. This becomes -8 plus this. So I'm going to add 8 to both sides to get the y-intercept by itself. So I have +4 is equal to c. So if I have my gradient and if I have my y-intercept, then easily the equation is going to be y equal to my gradient beside the x and my y-intercept right here. So the answer is y is equal to -2x plus 4, right? Have that and we're good. Doesn't get harder than that. Doesn't get harder than that, right? Does not get harder than that. So the B part to the question now, B part to the question now is a function question. It says two functions f and g are defined as follows. So it says f of x is equal to 3x plus 1 and g of x is equal to x squared. find in its simplest form an expression for f of x minus 2. Now, this is the f function, and it is equal to 3x plus 1. This is an input. All of this is the input. The input is the part of the function that comes in the bracket. So that's the input. All you're going to do is to place it where the x is. So if they ask me to find f of x minus 2, then I'm going to put x minus 2 where the x is, and then I keep working. So as you could see, what we want to do here is to distribute the 3 times the x. So we're going to distribute 3 times x give us 3x. 3 times negative 2 gives us negative 6. Then we add 1. Finally, 3x minus 5. And that is equal to f of. So if we're finding f of x minus 2, you should get 3x minus 5 if everything is done accurately. All right. And remember the input, the idea is that the input comes in the bracket right here. So all of that would be my input. That's all. Now let's take a look at the other question. Now for this question, it's a little bit tricky. This is your input right there. Your input is just the part in the parentheses in the bracket. So the g function says that g of x is equal to x squared. Let me make sure that that's what I have here. G of x is equal to x squared. It doesn't mean I'm going to square everything because I only can input things where the x is. So I'm going to evaluate g of x, g of 3x plus 2. Then I'm going to add 10 to the whole idea. So let us look at this. I'm going to do this now. Notice, you notice that part that is in the bracket. This part is the only thing can go where x is. So all I'm going to do is that is the part that will be squared right here. So that becomes x squared. And when we're done squaring x, we add 10 to whatever result we have. All right. So in this case, you want to take your time to work this out. For example, 3x plus 2. I want to multiply that by 3x plus 2 right here. So whichever way. So 3x times 3x is 9x to the second. 3x times 2 is going to give us positive 6x. So 2 times 3x is positive 6x again. And 2 times 2 will give me 4. So basically this part is 9x plus 12, 9x squared plus 12x plus 4. So let me put it here. I'm getting 9x squared plus 12x plus 4 plus 4, and then there was a plus 10. All right. So all we're going to do is to finalize it. 9x squared plus 12x plus 14, and we're done. All right. And we're done. So we got to be careful here when we put this together. All right. So let us now keep going, keep going, keep going. That's 9 marks again. We're at question 5. So question 5 is statistics, as you all know. So it says Mr. Morgan administered a spelling test to his class. The table below shows the number of words, right? It shows the number of words out of 10 that each student spelled incorrectly. All right, no problem. Number of words, it's up here. The frequency, as you know, would have been the number of times each it would have come, right? So let's see what they want. They said for the data set shown, state the mode. If you're going to state the mode, you're going to have to look at the frequency. So our focus has to be here. So we want to look for the biggest frequency, which is 8. So when you see the biggest frequency, you're going to pick up the number of words. So the mode is going to be 5, not 8, right? So the 8 is just going to show you what to select from your data set. So in other words, 5 would have came 8 times. That's what we're saying, right? Now the median is the middle term. Now, to find the middle term, you want to total your frequency. So we're going to add, what we're going to do is to add the 4 plus the 3, that is 7 plus 2, that's 9 plus 2, that's 11 plus 4, that is going to give us 15, and 15 and 8, that's about 23. So the total here is about 23, right? Let's double check, make sure that we get, let me double check. So this is 12, 14, 16, 16 and 7, 23. All right, good. So the total there is 23, right? So to find the position of the median, we can quickly do this. It's going to be 23 plus 1 divided by 2. In this case, is 24 divided by 2, and it gives you 12. This is not the answer. This is going to help us to find the answer. So we're going to do a cumulative check from right to left and then left to right. In other words, I'm going to be adding 8 plus 4 is 12. That means I'm going to stop here. This is saying that when I'm adding going from left to right, it is suggesting that I need to stop here. Now I'm going to move from right to left coming this way, but I'm going to do a cumulative check until I reach the number 12. So let us go now. 4 plus 3 is 7, plus 2 is 9, plus 2, that's 11. And then when I add 4, it's going to pass 12, so I stop. So what this is suggesting here is that both of them are telling me that my median number of words would have been 6, right? So the median number of words would have been 6. So the answer for this would have been 6 right here. All right. So we have to remember the little details, man. Put it together. Not a big deal. Next question says, calculate the mean number of words. All right. So if I'm going to find the mean, remember what the mean is, right? So the mean is equal to the sum of the fx over the sum of the f. So I'm going to have to create a fx column or a fx row in this case. I'm going to create a fx row, find the f, the total for it, and then I keep working. So let me put this together now. Let me clean up this a little bit. All right. So I'm going to create a fx. So fx is going to be down here for me. So it's going to be f times x. So this is my x and this is my f. So I'm going to multiply. So if I multiply 5 times 8, I get 40. If I multiply 6 times 4, I get 24. 7 times 2, I get 14. 8 times 2, I get 16. 9 times 3 is 27. 10 times 4 give me 40. And all I'm going to do is to add up all of this. So I'm going to actually add up all of that. So let me double check to make sure that I have everything. 40 plus 24 plus 14 plus 16 plus 27 plus 40. What am I getting? I'm getting 161. So I'm working with 161 over 23. All right. So this total gives me 161. So let's go with right here. So then this is going to give 161 over 23. Divide that out. 161 divided by 23, and I'm getting 7. Let me check it again. 161 divided by 23. Boom. I'm getting 7 for my thing. So I'm getting 7 right here. All right. 7. All right, let me double check these numbers again because you always have to do 12, 14, 16. Yeah. All right. So this is good. So we're looking at 7 right there. So that is my mean. All right, let's keep going. All right. So as you can see, this thing that we have done this on so many occasions. Like we have done this on so many occasions where we are actually utilizing the cumulative frequency curve to answer some questions. So what I'm going to do is that I'm going to take the cumulative curve to a screen that I'm able to adequately pick up the values from it. Let's put it to this screen. All right, let's blow the screen up. All right, this is all right here. I think it's okay right here. All right, so, all right, this is good. All right, so there it is that we have that right here. So let us take a look at what the questions are like. Let's see what the questions are like. First, so let's read it. It says here that the attendance officer at a particular school recorded the time, which is t in minutes, taken by each student in a group to travel to school. The data collected is shown on the cumulative frequency curve. All right. So we have the number of students on that side, and then what we have is the time here. Using the cumulative frequency curve, find an estimate. So we want to find an estimate, all right, of the number of students who took at most 32 minutes to travel. At most will be 32 or less. So at most 32 or less. So what you want to do is to find 32, right? On your look, we start off with minutes. So we're going to go where the minutes is, right? So 32 on our minutes based on the scaling. We're going to grab that. It's going to be, I could blow this up for you. It's going to be right here. This is 32 right here. And you're going to move this up to the curve. This is 32. And the moment it touches it, that's where you stop. And then you want to take it across, right? You want to take it across over here. And then you want to read off that value over here. There you go with that value over here. So basically then what we're looking at is, all right, so this is all right. So what I'm looking at here is I need to read off this value. So based on the scaling, remember now 20 divided into 5. So if you divide 20 up into 5, you're going to realize each line is actually 1. So it's actually 4. Each line is 4. So this is 42, then 48. This is 52. So this becomes 52 students. And remember, it says at most. So it is lower than this. So it is everything up to 52. So the answer for this question is 52 students. All right. Would have taken that time. So let us go. So for this, based on the graph, we're getting 52 students right here. 52 students. And that's a 1-mark question. The next question says the interquartile range. So in order to do the interquartile range, what we want to do is to make sure we write down what it is that you need to do for interquartile range. Interquartile range suggests that you're going to find Q3, take away Q1, and then you divide it by So hold on. So it's Q2, Q3 minus Q1. Let me write by this. So this is Q3 minus Q1. That's it. So this is your interquartile range. So what we're going to do is to find them, we subtract them, and we're done. So let's go find them, all right? So remember, though, that Q, let me clear off these markings from the graph. All right. Remember, though, Q1 is 25% of your sample. So you want to find 25% of your sample, right? Your sample is 220. I don't think you were told, but you could see there. Attendance records, all right. All right, you can see, because when you use it, when you're dealing with your cumulative frequency curve, the last number up there where the curve toppers off is 220. So you're going to find 25% off 220. But that's not going to give you the answer. It's going to help you to find the number that you need to work with, right? So 220 divided by, where we get 55. So I want to go where 55 is, and I'm going to bring that to the curve and then read off, right? Want to read off. So all right, let's find 55. All right, so 40, remember though, let me blow this up. Let me blow this up. All right. Remember though that this is, we're going up by 4, so 40, so this is 44, 48, and this is actually 52. This is 52, this is 56. All right. So it's between 52 and 56. I'm going to just draw the line between that. So I'm going to take the line between 52 and 56. It's not 56, it's just a little below 56, basically. Right. So right there. So whatever I get there, I'm going to have to work with. Right. So I'm touching the curve there. I bring it down here. All right. So that is actually my Q1, and it looks like 32. So my Q1 is 32. So I'm going to put my 32 there for my Q1. My Q1 is 32. So I have 32 here. All right. Let's go back for Q3. Q3 is 75% of the sample. So 75% of 220. 75% of 220. That's 165. 165 is not the answer. We're going to use 165 to get the answer. So 165, let's count again. All right. Remember, we're counting by 4 for this. So this is 164, 160, 164, 168. So 165 is between 164 and 168. So it's going to be just between this, almost 164, but just between this. I'm going to bring it here. I'm going to try to take it closer to 164, basically, right here. All right. I'm seeing the line that it is touching already. So hold on, let me put it right here. All right, good. So I'm going to bring this down, and then I read this off. So this is Q3 right now. All right, so that's Q3 right there. All right, so that's Q3 right there. So this was 32 for Q1. Q3 is actually 52, 54. This is 54. I'm getting 54 there. So my Q3 is 54. So all we're going to do is to subtract 54 minus 32, and we get 22. That is your interquartile range, 22. So the interquartile range is 22 right there. All right, let's keep going. The next question says the letter in the word positivity are each written on separate cards and placed in a bag. Dacia picks 2 of these cards at random with replacement. With replacement means that when she picked them, she drop it back. That's it. You picked it up, then you drop it back. So what you want to do here, that want us to find the probability that she picks the letter I, then. All right. So she will have to pick the letter I, then pick the letter V. You need to know the total letters that we have. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters here. So we have a total of 10. So we're going to pick I first. I. What's the probability to pick I? Right? Probability to pick I. So if we want to pick I, the probability is going to be how many I's? 1, 2, 3. So the probability to pick I is 3 out of 10. What's the probability to pick V, right? So if we want to pick V, what's the probability? 1V, so it's 1 out of 10. Now, if you're going to pick them one behind each other, it means that you have to pick I and then you have to pick V, which means that you're going to have to multiply to get the result. So you multiply these, you get 3 over 100. And this would have been the probability to pick a I, then you pick a V right after that, right? So the probability for that is 3 out of 100. All right, we are at our measurement question, question 6. So question 6 says, in the diagram below shows a gold bar in the shape of a trapezoidal prism. Its volume is 2,886 cm cube. The length and the height of the prisms are indicated. All right, so we're looking at that. Calculate the area of the cross section. So the cross section is the shaded area here. Remember that volume, right? Remember that volume is actually equal to. So volume is equal to your cross section area times your height or your length, depending on what you're dealing with, right? So volume is your cross-section area times the height. So in this case, the volume was given, right? So all we're going to do is to substitute. So watch this. So the volume was given as 2886. So the volume is equal to my cross-section times my height, but my height is 8.72. So if I divide both sides by 8.72, it's going to give me what the shaded region is. Just like that. All right. Oh, and it's not even 8.72. My bad. It's the length. It's the it is 31 point this. Because this is the shape. So let me just grab the shape for you. See the shape still here. All right. So this is basically the shape. So it's this we're dividing by. So in this case, it is long, like it is long. Based on how it's set, let me use L here. Let me use L here. So this is actually 31.2 that we're going to have to divide by. So we're dividing by the length of the idea. So we have the cross section here, and the cross section goes 31.2 to the back, right? So when we divide that, let me divide this, 2886, let's divide that by 31.2. We're getting something like 92.5. So it's going to give me that the shaded area is 92.5 cm square. So the shaded area is 92.5. That. All right, the next question says here, the cuboid shaped gold bar shows below has the same volume, right? So that means already we could write that, hey, the volume of this is going to be 2886 cm cube. We got that. So the question is calculate the height. So as you can see, volume is always the same concept. It's the area of the base or the cross section times the height in this case. So the area of the base would be this bottom part, which is the 8.2 times this. So we're going to have to multiply these to find that, right? So basically, what we're going to do is that the height here is going to equal to take the volume, and we're going to divide it by the base area. In this case, 2886 divided by 30.6 times 8.2. Let's see what that gives. All right, we're getting 11.5. 11.5 centimeters. All right, so that is the height. So basically, you want to find the base area here and divide it into this, and we're going to get that. Let's see what the other question is. All right, so this question, oh, that's the same thing. Let's see what the other question is right here. So it says the trapezoid gold bar is melt down. If you melt down something, there is one idea that remains the same: volume. Volume remains the same. When you melt it down, as long as nothing wasn't thrown away, we still have the same volume, right? So we melt down the gold bar and we turn it into, what is this? Gold bar is melt down, and all the gold bar is used to make 6 identical spheres. All of it is made. Okay, is used to make 6 identical spheres. All right. All right, good. Calculate for each sphere of gold its radius. Remember now, this is 6 identical. 6. So this is the volume for 6, right? So what I could do is to change this and work with 1, because this is the volume for 6, right? So it's made, let's read again, the gold bar, the trapezoid gold bar is melted down, and all the gold is used to make 6 identical spheres. So what I want to do, this is for 6. I need 1. So basically for one sphere is going to equal to take this and to divide it by 6, because we want to divide that into 6 pieces. So this is actually 481 cm cube for 1. Now I could now make the link, because remember the formula for volume is actually, we got it here, 4/3 pi r cube. So basically then we're saying 481, right, is equal to, which is the volume of 1, is equal to 4/3 times pi. They say use 22/7 times r to the third. So 4/3 pi r cube. And that's what we have here. So all we're going to do is just to take our time and we work it down. This is 88/21 r to the third, right? So what I'm going to do is just multiply both sides. I'm going to reciprocate the fraction so it goes easy. So I'm going to multiply by 21/88, so that the 21 cancel 21 there, the 88 cancel there. So we have the r cubed by itself. So let's work up the left side. 3. So 481 times 21. Then divide that by 88. This is giving me 114 point, I could just say 0.78. And this is equal to r to the third. So if I'm going to take r now, all right, you're going to have to find the third root of this. Cube root. So cube root. So let us find the cube root of that. Cube root of 114.78. And I'm getting that r is equal to 4.86, right? cm. So that is the radius for 1, right? Remember, the reason why we divided was that information here that was actually, it was says that we have 6 of them. So that's for 1. So that's the radius for 1 right there. All right, let us look on surface area now. All right, so now the surface area of a sphere, all right, is given by this. I have the radius, so all I'm going to do is that surface area is equal to 4 pi r squared. In this case, it's going to be 4 times pi times r squared. All we're going to do is work this out. So let's just use our calculators. 4 times 22 times 4.86 squared. I want to divide this by 7. And we're getting 296.93 cm squared. So this is the surface area for 1. Yeah, surface area for 1. So it's all about just putting together the idea and we're good to go. All right. Now this says density is equal to mass times volume. So all right, so we want to calculate the mass to the nearest kilogram, given that the density of gold is this, right? So the density of gold is that. Now all right, the surface area A of all right, so we only found the surface area for 1 gold bar here, 1 of the sphere, just 1 volume of a sphere. All right, good. So we find that. All right, so mass to the nearest. So remember though, all you have to do is to transpose here. So mass is equal to density times volume. All right, so we want to determine the mass to the nearest. Want to determine, calculate for each. This is what I'm looking for. So this question is working on 1 of the polar bar. So be careful of the volume we're going to use for each sphere. So we're going to have to use the volume of 481 in this case, because it's for each we're dealing with. That's why I was looking. So the mass is going to equal to density, which is 19.3 times the volume 481. So it's straightforward, 19.3 times 481. And this is going to give us 9,283.3, but this is gram. The question says to the nearest kilogram. So remember now, we're going to have to divide by 1,000, and it's going to take us to 9.2833, but to the nearest kilogram, it's 9 kilogram, rounded off, right? 9 kilograms. So that would have set that one there. We're done. We're going into another question, right? Question 7 is the observation question. Let us take a quick look at what we're dealing with. So it says the diagram below shows a surface, shows the first 4 diagrams in a sequence of rectangular hexagon. Each hexagon is made using the sticks of units. All right, so we have figure 1, diagram 2, diagram 3, diagram 4, and we're supposed to represent. It says complete. Oh, that means they start this one for us. All right, look at the pattern. We're seeing 1 on top of 2, for the first figure, and for the second figure, we're seeing 2 on top of 3. For the third figure, we're seeing 3 on top of 4. For the fourth figure, we're seeing 4 on top of 5. So that means for the fifth figure, I'm going to see 5 on top of 6. That's all I'm doing. 5 on top of 6. So this is 1, 2, 3, 4. I'm going to create one more here. This is my fifth one. So that is my sixth one there. And then I'm just going to create 5 up here. 4, 5. So for this one, now you're seeing 5 on top of 6, and this is good to go. So that's what you need to drop right there. And you collect 2 marks for that. Let's see what the table looks like. Now for the table, it says the number of regular hexagon H and the number of sticks S and the perimeter of each figure P follow a pattern. The value of H, S, and P for the first 4 are shown in the table. Study the pattern and then use it to answer the question. All right. So normally when we're doing this, all we want to do is to go fill out the nth row first, this, and then you use that to answer all the questions. So let's take a look. First things first, is there a difference, a common difference? If yes, then it's easy. Common difference is 2. If I subtract, I'm getting 2. What's the common difference here? Common difference here is, this is 8. This is also 8. And we're seeing 8 for the common difference. All right. Now, if we have a common difference, this is 4, this is 4. So if I subtract 12 from 16, 16 from 20, 20 from 24, I'm getting 4, which means my nth column should easily be done. All you have to do is to take your common difference, put n beside it. So this becomes 2n. So you could test yourself and say, all right, let's work this one out. 2 times 1 is 2. How did we reach 3? 2 plus 1 gives 3. That works. If you want to try it on another one, like 2 times 2, 4 plus 1, 5. So that works already. You could try that for the rest, but it works, works. So you try it with 2 of them and you see. Now, this is going to be 8n because the difference is 8. So it's 8n. So you could say 8 times 1 plus what give 15? 7. You could try it on the other one. 8 times 2, 16 plus 7, 23. Then you move on. Just to what you just want to secure that idea. For this one, the common difference is 4. So you could say 4n. And then 4 times 1 is 4 plus how much give it? 12, 8. So that means for this pattern, it's going to be 4 times n plus 8. So if you want to try it on one more, like you could say 4 fours, 16 plus 4, 24. So it works, right? So this now you can use that to fill out the rest of things in the table easily. For the fifth one, it was very easy. I could just put 11, all right? And based on the pattern, I could just add my 8, 39 plus 8, 47. Because I'm still in sequence because first, second, third, fourth, fifth. So everything is still running in a sequence. So I could just put those in, right? Now for the rest, I'm going to use my table to just get them out. So, right, if this is 47, I could use 2n plus 1 to help me here. So think about it. 2n plus 1 gives 47 because this is in the column with 47. So you can solve for n. So 2n is equal to 46 divided by 2. N is equal to 23. This is 23. Now, if I know that n is equal to 23, I can find this over here, this blank spot, right? Because it's going to be 4 times 23, then I add 8, right? So 4 times 23 plus 8 gives me 100. So this right here is 100 right there. All right. Oh, we're done. Right. 1, 2, 3, 4, 5, 6, 7. Okay. All right. So easily done. So basically, this one was very simple and straightforward. It says, Kyla says that she can make one of the figures with a perimeter of exactly 1005. So you're going to go under the perimeter column. See the perimeter here? So for the perimeter column, we're working with 4n plus 8. That means she's suggesting that 4n plus 8 should equal to 1005. So 4n plus 8 is equal to 1005. If she's correct, I should get a positive integer for n. So n cannot be a decimal, n cannot be negative either. So let us try to work it out. Let us subtract 8 from both sides. If I subtract 8 from both sides, then 4n is going to leave me with 1005 minus 8 is going to leave me with 997. So I need to divide 997 by 4. Let's divide that number by 4. And n is not what we're looking for because we're getting 249.25. This is a problem, right? So so explain why she's incorrect. She is incorrect because n has to be a positive integer, right? So this is the key here. N has to be a positive integer, and we got that n is equal to 242.25. So this is the problem. This is not an integer. N has to be a positive integer for that to be correct. So no, that is why she is wrong. N has to be a positive integer. All right. So with that said, or you could say, so at the end there, the number has to be divisible by 4. It didn't work. So you collect your 10 marks. We're at question 8. Question 8 now says the function f and g are defined as follows, right? So f of x is equal to 2x minus 1, and g of x is 5 minus x squared. They want us to find g of 2. So I'm going to take the g function. Remember, g of x is equal to 5 minus x squared. So if I'm going to do g of 2, I'm simply going to substitute 2 where the x is. So this is going to be 5 minus, so this is going to be 5 minus, hold on, 4. Okay. Okay, 5 minus 4, which is equal to 1. All right, very good. So 5 minus 4 is equal to 1, and we have that for g of 2. The next question, we want to do the inverse of f of 3. So let me put the f function here. What we want to do, though, for a question like this is that you want to find the inverse of f first, and then we're going to input the 3 in it. So remember now, let's y equal to f of x such that y is equal to 2x minus 1 over 3. The first thing that you want to do is to switch x and y. So x is equal to 2y minus 1 over 3. Then transpose to find y. Multiply both sides by 3. So we have 3x equal to 2y minus 1. That would have canceled. Then we're going to add 1 to both sides. So basically, I have 3x plus 1, which is equal to 2y. Then I'm going to divide by 2. So now I have y is equal to 3x plus 1 over 2. So I'm going to write the real thing, though. The inverse of f is equal to 3x plus 1 over 2. Now I'm going to find the inverse of f of 3. So the 3 is going to go where the x is. Add 1 to it, divide by 2. 3 is 9 plus 1 over 2. 10 over 2 is definitely 5. So we're looking for 5 as the answer as you go for that one. Let's go for the other question. So the other question says, derive an expression in its simplest form for f of g of x. All right, so f of g of x, let's grab the f function. The f function says we have 2x minus 1 all over 3. And the g function was given as 5 minus x squared. What we're going to do is to put the g function in the f function. For example, the moment I'm asked to represent, right, f of g of x, I'm going to have the g function where the x is, right? So let us just throw it out. So the g function is 5 minus x squared. There is still a minus 1 here all over 3. As you can see, this is the g function right now in the thing. So at this now, you're going to distribute this and distribute here. And then let's see what we have. 2 times 5 gives us 10. 2 times negative x squared is negative 2x squared, right? And there's a minus 1, which is differently, and everything is over 3. We're still there. We can handle our like terms. 10 minus 1 is going to give me 9. So this is going to give me 9 minus 2x squared all over 3. And this is the final result because I cannot simplify this anymore. So 9 minus 2x all over 3 is the answer for that. All right. So let us keep going. Right. Let's see what's coming up next. All right. So this is what they want us to do. They're saying sketch, right? They want us to sketch the graph of the function g. Right. So we want to sketch g of x here. And what they want to do is to make sure that we indicate the maximum or minimum. This function has a maximum. So we're going to indicate its maximum and then the roots. The roots would have been the solution. In other words, then, if g of x is equal to 5 minus x squared, I need to know the solution. Let this equal to 0, and then I solve 5 minus x squared. Then I could add x squared, if I want to have positive x, all right? So I have x squared is equal to 5, which means if I take the square root, I'm going to have to put a plus or minus. X is equal to the positive root of 5. X is also equal to the negative root of 5. So in other words, then, I am good now to do this sketch because they only want the roots. So I'm going to just put up my roots of 5 wherever I want to put them, right? Wherever I want to put them. So I could put them right here if I want. So if I say this is where my root 5 is, and so my negative root 5 is somewhere here, like there, right? So if I'm using, it's up to you. So I'm using right here as my root. Another thing though, if I'm counting 1, 2, 3, 4, 5, I could put my, because remember though, the constant here is a 5, right? That's a 5, which means that that's a 0, 5. That is x and that is y. That's my y-intercept you're looking at all times. That's my c value. So therefore, my c value is right here. So my key spot that I have in terms of to deal with is right here, right here. Those are my two roots, and right here is my intercept. And then I'm just going to grab my curve from here. So I'm going to have to. So this is a rough sketch of the idea. That's it. So that's the sketch that they wanted. They wanted us to highlight our maximum, all right, our maximum point. So right here is we have 0, 5. That's my maximum point right here. And these are my x-intercepts, which are what we call our roots right there. That is all that was required in terms of responding to that question, and we're done. For this other question, no, I think I have to take this to the graph. Uh, sorry for the question doesn't look 100, but we have to use it. We have to use it anyway. All right, let me see if I could get it straight a little bit, maybe. All right, I'm gonna have to leave it like that. All right, context for the question. Let's see what they want. Let's go back to see what it is that they want from this question. So from this question, it says, on the grid, draw the tangent to the curve at x equal 1. So you want to draw it, to get 1 mark to draw that. So let's draw it. So x equal 1 is somewhere here. Right here is x equal 1. So I'm going to draw a tangent. And remember that a tangent only touches the curve once, right? So it's like you're going to have to make sure. All right, let me blow this up a little bigger. Blow this up bigger. I'm gonna blow this up bigger to get a thicker line. Give me a minute. All right. So I'm gonna let it pass right where my red dot is. So this is my curve right here. So I could just take it and I'm gonna put it right here. So I'm gonna make sure that it only touches it once, like that. All right. So that is basically my tangent at the point, right? That's me, the tangent at the point right here. Right here. I'm saying that's a tangent right there. That's what I'm getting. That's what I'm getting right there. That's what I'm getting right there. I'm getting that right there. All right. Now, so you would have gotten 1 mark if you actually do that. Getting 1 mark if you do that. Now, let us see what else we can actually do, right? Let's see what else they want. The next question says, use the tangent. So That same tangent that we just put on, they said estimate. So this is not a real thing. We're not going to get a real thing, but a good estimate for the gradient at where x is equal to 1. Concept for this question is that the gradient remains the same for every straight line. All right, so if I can just find the gradient anywhere on this rise over run, or any numbers I could pick up for this straight line. So if I am trying to pick up 2 points on the line, we should be able to do something here. All right, we can. All right, let us quickly look at this. So if I pick up this point here, this is what I'm getting. So this point here, I know where that is, right? I could use back even this. I'm seeing a point here. Remember, this is not perfect, but I'm seeing a point here. So I'm just connecting these. All right. I'm seeing points here, and I'm seeing. So this is what I got right here. So what I'm going to do is just to pick up my rise over run. I think I can actually do that. So for my rise, I'm seeing how many units? 1, 2, 3, 4, 5, 6. This is 6 right here. All right, so that's rise because I could do that. Now for the run though, you have to take a look at you have to look at the scaling. But watch this. Watch this. This is 1 already. This is from right here to right here is 1, and this is a nice spot I have. So 1, 0.2, 0.4, 0.6. Okay, 0.2, 0.4, 0.6. Oh, 0.25, 0.5. Okay, so it's 0.25. So, all right, nice. So this one gap is 0.25. So all of this is 1.25 I'm getting right here, 1.25. So then my slope, okay, I have some good numbers here. It's going to be 6 divided by 1.25, and it's going to just give it to me. Might just be, that looks like about 4.8. So this is giving me exactly 4.8, which is approximately 5, right? So basically, there are diverse ways to pick up these, but I just kind of utilize a nice aspect of it. But they did say that an estimate. So I'm estimating 4.8. I'm running off to about 5 for that right there. What I did, I just picked off 2 points and just make a triangle. And from that, I just could do rise over run, and then we go here. But you have to take into consideration the scale because 1 is here, 0 to 1, and then this is a quarter of the journey, and that is why I just picked that. All right, so let us go to the next question as we go. All right, so we got our slope here to be approximately 5, right? Good. All right. We are at, what question are we at now? Going. All right, so this one says write down the equation. Okay, write down the equation of the tangent. All right, write down the equation of the tangent in the form y is equal to mx plus c. Now, if I'm going to write down the equation of the tangent, let me tell you this. The only thing I'm going to do is that I'm going to use that slope that I have for it and the y-intercept. Remember, for any equation of any line, if I have my gradient and if I have my y-intercept, I'm going to represent it in slope-intercept form. Y is equal to mx plus c form. So remember now that the slope was actually 5. And then I'm going to look to see where my line crossed that y-axis. So it crossed the y-axis for me at, this is negative 1, 0.2, 0.4, 0.6. So it passes it for me right here at negative 1.6. That's where it passes it for me, all right? So I could use that right now. So I'm just going to do that. So it passes it at negative 1.6. So this is the equation of my line. Y is equal to 5x minus 1.6. There you go. So that is what I'll drop there for them and move. In other words, it's a 1-mark question because everything was already vividly there. You can look, you could see, you pick it up, and you move, right? Let us see what else we have. We are at number 9 now, geometry and trigonometry. So this question says V. Let's go for that. It says V, X, Y, and Z lie on the circumference of a circle with center O, with the diameter YV. UV is a tangent to the circle at V. So we're looking at all of those stuff that they're giving us. All right, no problem. We have the angle 62, we have 18, we have everything that we need. So let's go to the questions now. Questions are as follows. It says state a theorem that justify. Remember, you know, all we're going to do here is just to state theorems that justify the values of each. B is 62. Well, let's take a look. B is 62. I probably could put this. Let me bring this to the other screen so I could look at the diagram at the same time, right? All right. All right. All right. So let's go for the notes right here. So we want to justify the fact that B is 62. Let's go. So you're seeing that B is actually 62, right? B is 62. Let me see the pen. You're too big. It's all right here. So B is 62 right here. Angling the same segment. All right. Even yesterday, we were looking at this. Into yesterday evening, same segment. They came from the same VZ. They came from right here and right here. Both went to the circumference of the circle in the same segment of the circle. See here, this is the line that segmented the circle right here. So it's angling the same segment are equal, and that is why we can easily say that, hey, that is 62 right here, angling the same segment. So we want to drop that here. We could say the theorem is surrounds angle in the same segment are equal. So angle in the same segment are equal. We utilize that and we're gone. Let us see what the other question is saying. We want to show that C is 124. 124. Let me see if they want it. All right, so we only write it. So C is 124. Let's go for it. C. Where is C? A, B, C, C, C. Oh, C is right here. Yeah. So C is gonna equal to 62 times 2, and this is 124 for real. So which means the angle at the center is twice the angle at the circumference, providing that they're standing on the end of the same chord. So they're standing at ZV, right? And then one angle went to the center, the other angle went to the circumference. So what we're suggesting here is that the theorem I would use for this is as follows. Angle at the center is twice the angle at the circumference. That's it. Or you could say the angle of the circumference is half the angle of the center, whichever way you want to put it. Let us go for angle OW, OVW equal 90. Let's go for that. So OVW, so they're saying this is equal to 90. Radius meets tangent, right? You could see the radius here meeting your tangent line. Always 90 degrees, and we're gone. Radius meet tangent 90, and we are gone with that. So this one is radius meets tangent at 90 degrees, right? And we're going with that. Next one, no. Radius meet tangent at 90. The next one. So this one, no, they're saying to us now, find the values of A, D, and E. Show all working where appropriate. So where it is appropriate, show the working. All right. So we're looking at angle at A. Let's look for A. Angle at A. Where is A? All right. A is right here. Okay. A is 62. A is 62. And there's no working I'm going to do for this one. Why? Because I'm seeing where it is the alternate segment. So if you look at this triangle right here, right here, the angle between a chord and the tangent is equal to the angle, the third angle in the triangle, which is in the other segment of the circle. So A is actually 62 by using the alternate segment theorem. And I don't have to work out anything for that one, basically. So this one, 62 degrees. They didn't ask for reasons, so we could move on. D. Now, remember though that this is, we got 124 here, right? And this is an isosceles triangle. If this is the center, from O to Z, is equal to from O to V. So isosceles triangle right there. So to find D, I'm going to do some working now. D is going to equal to 180 subtract 124, and then I'm going to have to divide it into two equal pieces, right? So 180, let me subtract 124, 56. Then I divide this by 2, I get 28. So I'm getting 28 for D. D is 28 degrees right here. That's 28 degrees right there. And we're going. All right, circle theorem wasn't too bad. E. All right, so I want us to find E, right? All right, so to find E, we can do a number of things to find E, right? And we're going to get E. Now, E, take a look. I'm going to highlight something, right? I'm going to highlight an idea here. This angle is equal to this angle. And that's called the alternate segment theorem again. So the angle between a tangent and a chord is equal to the angle in the alternate segment. If I could show you what I'm focusing on, that triangle with this angle and that tangent line, right? So so then I now could say that this angle right here is 90. Remember, this is 90. This is 90, right? We got that already. So 90 minus 18 will give 72. All of this is 72 right now. So if I take 28 from 72, I'm going to get the angle there. So basically, what is the working I'm going to employ here? I'm going to find 72, take 28 from 72, and I'm gone. So basically, 90 minus 18 will give 72. And then if I take out the 28 out of that 72, it's going to leave me with 44. So in other words, then, this is suggesting that this angle right here is actually 44 degrees. So if I should add 44 plus 28, I get 72, which is equal to 72 here. All right. So that's not the only way you could have done it, but that's the way I just did it. And we're moving on. We're on some tricks question now. It says, diagram below shows a quadrilateral PQRS formed by joining two triangles PQS and SQR, right? Now, let's take a look at these, right? It says calculate the length QR. All they want me to do right now is to calculate this length right here. But remember though, I have an angle between two known sides. So all I'm going to do is to use my cosine rule, man. So cosine rule suggests that 16 square plus 18 square minus 2 times 16 times 18 times the cosine of 25 degrees. And it's going to take me there. 16 square, come on. 16 square is 256. 18 square, 324. And then I'm going to put all of this on my calculator right now. All of this, I'm going to put on my calculator. So you're talking about negative 2 times 16 times 18 times the cosine of 25. Right? And what am I getting? Getting minus 522. Okay, there's a 0.0, so I'm just going to say minus 522.03. I'm going to leave that. All right? So from this now, we could just sort this out. So we're talking about 256. 1 second. Checking off. I'm checking off. 256 plus 324, and then I'm taking 522. All right, making sure the numbers are actually good. Yeah, numbers are good. And I'm getting 58. All right, good. So we have 58 for this here. And then I'm going to have to take, so for QR, I'm going to have to take the square root of 58. And that's going to give me about 7 point, let me take the square root, 7.62 meters. This distance is 7.62 meters. And we're done. So we employ the cosine rule right there. And we're good to go. Let us now jump on to the next question. So we're right back into bearings. It says here, the bearing of P from S is 205. Let me mark it. Probably want to. All right, let me bring this to the other side, please. Let me just bring this to the other side. All right, so we have this now. Let's get on it. Let's get on it. All right, let's get on this. It says here, so we are at this question. It says the bearing of P from S is 205. All right, let's mark that. P from S is 205. P from S. So that means from S, we'll do our knot line. We'll always put the bar knot. So from S, all of this they're saying is 205. No problem. All right, this looks nice. So that is 205, the bearing of P, but from S, all right, is 205. So having had that, right, what do they want? They want the bearing of R from S. Now watch this. They want the bearing of R from S. We want R from S. All right, no problem. Let's take a look at the diagram. R from S. We want the bearing of R, but from S. In other words, I want this bearing only. So for this question, so R, but from S. All right, no problem. All I'm going to do is to subtract 72, the sum of 72 and 25 from 205, right? That is all we have to do right there to get that bearing, because you're seeing here that this piece is the missing piece that we're looking for out of the 205 right here. That's the bearing that we want, right? So we could simply subtract. So for this, what we're going to do is to have our 205. Then we're going to subtract, what are those numbers? One was 72 degrees. The other one was 25 degrees. So it's 205 minus, let me see what that number is. That's what, 97? So we subtracted 97 from this. So let us just balance that out. 205 minus 97. That's 108. So this answer is 108 degrees. So that's the bearing right there, 108. Let me label the diagram. So this is actually 108 degrees. All right, very good. Let's see what the other question was. It says the bearing of S from P. Be careful, from P. S, but from P. So let's look. S from P. So at P, I need to put my north line at P, the bearing of S. So step up to the north of P, then this. We want to find that angle right there. Let me just color code it for us. This angle right here in this corner. We need to find this angle right here. There are many things that we could do. I'm going to color what I want to do. So I'm going to color this piece. You see this green that I'm putting here? I'm going to look at this green right here. Right here is a full circle right there. 205, 205, if I take 205 from 360, I'm going to get my green angle here. This green angle is what I'm going to use to solve my problem right here, right there. So if I take 205 from 360, I will have that value, and then I'm going to use co-interior to write out the storm right there. So let me just do it right here. So I'm saying that 360 degrees, take away 205. Right, let's subtract that. 360 minus 205. This is going to give me 155 degrees. That's not the answer to the question. It is this angle here that would have completed that 360. But remember now, when we have parallel, the north lines are parallel. So this angle here and this angle here are co-interior, right? So that means they are supplementary. They add to give 180. So if I take 180 and I subtract 155 from it, right? So it's going to leave me with this angle as 25 degrees. And there it is, right there. We're done. 25 degrees right there. So it's all about putting together all the little principles and ideas and walk ourselves through it. So we just got that 25 degrees. We're at question 10. And last, we're at the vector and matrices question. Let us see what they gave in this section. It says determining the determinant of the matrix 6, 2v, negative 5, negative v is 24. What is the determinant? Determinant is always the product of the main diagonal, subtract the product of the other diagonal that is not made. So what we're going to do is have 6 times v. So this is negative 6v because we have a negative v, which is going to minus negative 5 times 2v, and this should give us 24. So let's simplify. Negative 6v positive 10v equal 24. All right? So negative CV. So in this case, what we have is positive 4v equal 24. Right? Divide both sides by 4. V is equal to 6, of which they asked us. So V has a value of 6 right there. So we're utilizing determinant. We work that out. So V is equal to 6. Now, let's continue with the question. It says the matrices L and M are defined as follows. So we're looking at L and M. They want us to evaluate the product. All right. So 9, 5, 3, 2. Row. Remember, when you multiply matrix, it's always row by column. So this is L and this is M, right? It's always row by column. So I'm going to highlight row 1, row 2, column 1. I'm going to label them as well. Row 1, this is row 2, and this is the only column that I have. So the idea is row 1 times column 1. So it's going to be 9 times 2 plus 5 times -4. And then row 1, column 1 is finished. I'm going to do row 2, column 1. So it's going to be 3 times 2 plus 2 times -4. All right, let's put this together. What are we looking at? 18 minus 20. Right, so we're looking at 18 with a minus 20 there. And then we have 6 with a minus 8. What are we looking at? 18 minus 20 minus 2. 6 minus 8 minus 2. Right? So we're looking at -2, -2. All right. All right. We're good right there. We're good. We're good. We're good. All right. So we're looking at -2, -2 right there. All right. Let's look now. They want the inverse of L. Let me write the L. So, all right. So I want the inverse of L. So this is the matrix L. Matrix L is as follows. It is 9, 5, 3, 2. We're going to do the inverse of L. The inverse of L is simply 1 over the determinant of L times the adjoint L. All right, so let us find our determinant. Our determinant of L is equal to the product of the main subtract the product of the other. So it is 9 times 2 minus 3 times 5. So this is giving us 18 minus 15, and this is 3. So the determinant is 3. Let's write what the adjoint is. The adjoint of this matrix is actually, so the adjoint L is 9 and 2 will switch place, and we have a -5 and -3. All right, so with the adjoint, you switch the main diagonals and change sign for the other diagonal, right? All right, so let us just put this to rest once and for all. So then the idea now for the inverse of L is going to be 1 over 3 times 2 -5 -3 9. This in its sense is already in itself is the inverse, but we're going to slide it in. So we're going to get 2 over 3 -5 over 3 -3 over 3 and 9 over 3. I want to break it one more time. 2 over 3 -5 thirds, -1 and 3. And let me give you some clarity. Any one of these, there are 3 responses here. All 3 you get the marks for. Anyone you submit, you're good. If you submit this, you're done. If you give this, you're done. If you submit that, you're done. Right? Based on what I've seen, they do take them. The fact that you're able to put it together already is the answer. So whichever one of these ideas you had, you would have been good. So matrix is actually wrapped up right there. Let us now jump onto the vector questions. They really give an easy vector this time. So it says here that, all right, PQ is actually 5, -4. If P is a point, -2, 3, right? Determine the coordinate of Q. Now, the moment they're giving you a point on your grid, that means you're dealing with position vector, which means that this coordinate for P as a vector will be OP. This is OP, which is -2, 3. Now, if they ask me for a coordinate for the point at Q, all I need to do is to go and find OQ. If I find OQ and I'm going to get it in a vector form, I'm going to represent it in coordinate form for the point Q. In other words, then, just as though I took the point -2, 3 and turn it into a position vector with OP as in -2, 3, we can find the vector for O Q, and then represent the coordinate. OQ means that I'm going to move from O to P and then travel from P to Q. Now, OP, we have OP in the same way, same direction, -3, -2, 3, plus PQ, we have it in the same direction, 5, -4. Let us not make any errors now. -2 plus that is +3, and then 3 plus -4 is -1. So what I'm looking at here is this is a vector. You can't leave the question yet. So this is the vector, the position vector OQ, which means the coordinate of Q is actually the vector itself, 3, -1. That is an X and that is a Y. So we have to be careful with how we respond to the question. But definitely that is the answer to that question right there. We're in the last part of this now. Let's go. So what I normally do with these questions, I label them quickly. So we have a pentagon. We have O, A, B, C, D, where OA is parallel to DC. We were told that OA is parallel to DC. All right, and you see the arrow indications here. They are parallel to each other. We got that. No, and AB is parallel to OD. We got this. They're parallel, so we have that as well. All right, let's keep going. Now, what information we got? OD is 2AB. OD is 2AB. If AB is just B, that means OD must be 2 times B, 2B, because it is 2 times AB. So you could put on the labels like that. Now let's see. So we just fix that. Now OA is equal to 2 times DC, right? So that means if you multiply DC by 2, you get OA. But we have the label for OA, and it is 2 times. That means DC is a half of it. So DC is a half A. So you want to look at it. So if you multiply half A by 2, you end up getting 1A, right? So here it is that we have labeled all the necessary details. Now we want to jump on solving the question now. It says, find in terms of A and B in the simplest form, A, D. So I'm going to have to draw my line here. I'm moving from A to D right here. And the direction is necessary, A, D, going that way. I'm going to walk. So this is going to be my triangular walk. I'm going to walk from A to O and then move from O to D. That's going to be my triangular walk. Let me write it up. So my AD is going to be from A to O plus from O to D, right? So that's how I'm going. Let us now finalize this idea. Now, AO, notice I'm going against the arrow because I got OA, but I am going AO, so it's going to be not A, but it's going to be the opposite of A. And then I'm going to utilize OD just the same, positive 2B. So we're done. That's 1 mark right there. We're done with that right there. Now, let's see what the other question says. It says BC. Take a look at what you want to do for BC. I probably could put BC somewhere here. For BC, right? If I'm going from B to C, I'm going to take this route. I'm going to go from B to A to O, O to D, D to C. I can do that, right? Or I could cut and come ADDC. Anyone you want to do, doesn't matter. All right, so you can do that. Or you could have, or, let me just give you your or case. You could have just done it this way. You could have said B to A to D, D to C. You still get the same answer. All right, so it's up to you which direction you want to take. You can just write them off. It's good to go. So let us just fit this in now. I'm gonna write anyone I feel to. I'm gonna go from B to A. Okay, and then I'm gonna go from, so if I go B to A, I could go from A to O, right? I'm just doing this, and then I go from O to D, and then I move from D to C. I'm just saying, you can do anything you want. It's okay. So now first, I'm going to go the opposite of AB. Look, arrow is going that way. That's not the arrow. Let me show you the arrow. The arrow is going that way. So I'm going to go this way. So I'm going to go negative B. So this is negative B here. Plus, I'm going against the arrow here again. So it's going to be negative A. OD is normal. So this is positive 2B. DC is normal. It is a half A. Color care like terms because this is vectors. So the B's, let's take a look at the B's right there. I'm going to change the color for my A's right here. So as you could see, I'm having, if I put the A's in front, if I have a negative A, right? I'm just going to write it. Negative A plus half A, and then I have a negative B plus 2B. This is what we're simplifying. So think about it. Negative A plus half A, I'm still left with negative half A, all right? It's like I have negative 1A, and then I add half A to it, I'm still at negative a half, and then negative B plus 2B is just positive B. So this is the vector for BC. Now, let us look at the other one. Let's see what else they want. What else they want? They want, are we done? Okay, we're done. All right, so we have our BC here. So look at what the question says now. The question for 1 mark though, this is just 1 mark. It says state the conclusion about, right? So we want to state the conclusion about the magnitude of AD and the magnitude of BC that can be drawn from the responses that we just did. Okay, so we're dealing with AD and BC. Let's take a look. Take a look. So both of them are here. I'm going to write the other one. Let me write the other one beside it. This is BC. It is negative half A plus B. Remember though that these, when you look, if one vector is a factor or multiple of the other one, they are parallel. All right, and you could see that they're parallel right here. They are parallel. These vectors are parallel. All right, so this is parallel to this one. They are parallel. Now, as you could see, I can multiply BC by 2, right? Let me put it at the side. So BC is here. This is BC. This is me multiplying 2 times BC just to prove the point. 2 times this, so it's going to have 2 times negative a half A plus 2 times B. Boom. So that's negative A plus 2B. So when I multiply 2 times the BC, I did get AD here. So they are parallel. Now, as it relates to the relationship, that factor, which is 2, it simply means that AD is twice as long as. So this is what we could write here. AD is 2 times as long. So then we could say 2 times the magnitude of BC gives the magnitude of AD. That's one way you could write it. Or you could say half the magnitude of AD equal to the magnitude of BC. All right, so various ways that you can represent the ideas to get the same mark. It's up to you. You could have said it the 2 ways. It's only 1 mark and the paper is finished. I think it was a nice paper. There you go. How much you get, drop a like, drop a comment, subscribe to the channel, share the video for the solutions, full solutions, fully loaded. See you next time. Bye-bye.